Oh, this lesson is related to Subsea cost database, Subsea cost benchmarking, Subsea cost estimation. The database I am showing you is the CAF Corporation database, which have two options. The cloud of and the content of this database, you can find SURF class 5 cost estimation benchmarking, which you click on the link and you go there. Subsea production system, you have two sub databases or two items included. The subsea process control umbilicals, and the subsea riser systems, the subsea flow line system, which contains 7 sub-items inside, the subsea manifolds and tie-in systems with 6 sub-items inside, the subsea process power and boosting system containing 3 items. All those items at the same time are separated in, let's call them separate databases. Additionally, there is a on the construction subsea DCAP OPEX database. So let's start going through this cloud, the database. Go there. When you stay in the cloud database, you can open it every accordion, and in this case you can see blue because the link at this level works. It works because you are inside of the database. It's only allowed to for member. Okay, let's click on the link. Okay, now we are in the link, and we see this is the SURF and class 5 cost estimation and benchmarking. Let's explain roughly, briefly, this a graph containing the relation, the interaction between the benchmarking and the cost estimate. In my opinion, all cost estimation start from a benchmarking. No matter if you are doing a civil works, process plan, cost estimation, subsea, topside, floating, whatever the estimation is, you need an information database, but the database is always coming from a benchmarking process, which is the collection of the information, is the benchmarking data collection, and organizing making some filters. You can let's say to prepare a good information to be used for the future, which is a cost estimation for as a tool for project decision making. So the process is a circle. You collect the data, you make the benchmarking output and present it in the best way. Then you use that in an estimation database. You you make your cost estimation, and then there is the purpose of the information is to review the estimate or making a benchmarking comparison, which is another activity where you can see your spot in a curve in order to see how accurate is your cost estimation. This is a process, a good practice, and I could say the best practice for cost estimation. Having a database, putting in a graph. These red spots are the sample of different projects, and then you can see how how accurate are you in the graph. So this is an example of when you compare subsea, in this case, subsea overall cost benchmarking, and you have different sample of projects, subsea cost, in this case per BOED, defined hydrocarbon throughput, and the spots are projects, but it's not convenient to show the project name for confidentiality, protection. And in the y-axis you have the cost, and the x-axis you have the driver. In this case, the BOED. It's just an example. Going back in this database, you have the different possibilities with the data collected, in this case, a non-deep water global worldwide projects. You can have a cost estimate classify tool, which it's you insert your information, the information you have in your project, you fill the name of your project here. The main items are estimate a recordable reserve, the number of wells, the design hydrocarbon throughput, the depth water, okay, and automatically the tool give you a classified cost estimation, but it's coming from worldwide projects around the world. It's a way to have a rough ballpark cost estimate. But I would say I would like to say that it's coming, since it's coming from real values, real cost, real projects, because it's the real value of the project, and you can try and see how powerful is this tool. So let's start making an exercise. If you have a project, let's say starting from the main parameters, the reserve, let's say is 70 million of BOE, barrel of equivalent barrel, okay, and the number of wells, default value 2, let's put 5. Design hydrocarbon. This is just a test. I'm not taking from any project. It's just for academic purposes. Let's put here 25,000 BOED because it's the total taking all these 5 wells. Let's suppose each of them 5. So 5 by 5 is 25. And then let's suppose the water depth is around 360 and the distance to host, let's say 42 kilometers far, but it's okay. And this cumulative length by diameter, it's procedure you have to do previously to fill this because it's the composed of all lines multiplying the length and the diameter and then summarize all of them. So let's suppose in this case it's 80. 80 remember, this is a multiplication, length diameter. Now let's put a little bit more. 90, just. And it doesn't affect only this a bit. Let's see. It's 150. 148 because it's a flow line cost. Let's keep the 80. So let's go now. We have 306 million US dollar this project. It is based on information from 2012. I am including the update in 3, let's say, buttons here to update automatically with the latest cost index. The next explanation, the next feature it's already done, but not in this table. So we have the possibility to add 25% of contingency. You could select whatever. But important is we have the total amount, $306 million in this project. Let's see the tool. It's you can confirm if this tool is giving you a good information. I have all curves separated by items. The subsea overall cost curve with more or less within 15 to 25 projects around the world. And how much is the subsea cost comparing with different drivers. The first chart 1 compare with the estimated recoverable reserve. The second with the BOED, the design hydrocarbon through put the chart 3, compare the total cost, the subsea total cost, with number of well multiplied by water depth, and the last just simple number of well. So we have four comparison, and each curve contain inside different statistical tools. Every one contain a particular statistical characteristic, like the R square, which is how strong is the curve comparing with the driver. So if you are an estimator, suppose you need to compare your estimate, you can do both ways. But if you're doing this way, you are sending to me an estimate. You can protect yourself. It's for confidentiality, not mentioning that the project, not mentioning the company, whatever. So it's just a profession to have a way to see how accurate you are. So if you click on the button, immediately I will receive this form. You put here your mail that I'm doing with myself. Mail, personal mail. Project name, you can put whatever, test, number date. Project location is important because it uses the database accordingly with the area. So if you say this in Africa, North Africa, you use the proper database. So then technical input parameters, the estimated MBOE, remember we have in our exercise 70, okay? So let's put 70 million barrel equivalent. Next, oops, sorry. Next, number of, I didn't see it. I didn't see. BOED again, BOED. It's 25,000. 25,000. Number of wells, 5. Water depth, oh, sorry, that is very sensitive. Water depth is 360. 360. Then, next, project cost estimation data. How much is your cost estimation, the overall cost? So in our exercise, we have 306 million. $306. But in the particular manifold well system cost, let's see, is 111 millions. So, okay. Flow line and umbilicals. Let's see. 148. Let's go. 148. Distance to host. distance to hot is 42 kilometers. 42 kilometers. And then the cumulative length, there is a small picture here with the explanation I have already explained it to you. It's you take home every single line, the diameter, the length, and multiply, and then summarize all of that. In our exercise is 80. So let's go there. 80. Let's continue. No more. It's okay. So we have finished. Go. And then I received the information here in this spreadsheet. And let's see. So we call it let's see, because it's this information. See, so I take this information, copy, and I put it on the yellow area. As value, and I have to put something here. I have to do something here because it's not this 42. I have to copy here because it's the host, and here is in another column. I have to fix this. Okay, let's go. What happened with the charts? First charts is this. Our spot, I don't know if you see, but probably not, is the MBOE is 70. Let's modify let's make a modification here. Okay, continuing with this, organizing the information. You have 437 costs per unit per million of BOE. The chart 2, let's organize. We have the spot inside the border of the green area. All the spots inside of these two green areas, the curve is this red curve, but you have green area. We used to call it green traffic light area. If the spot is far from this green area, probably depending on the deviation, we can define the yellow traffic light, and if it is too much far away, it's red. It means that you have to correct, you have to fix your estimate. In this case, you are okay. Okay, let's go. But this is Subsea versus BOED. The next is the subsea versus number of wells and water depth multiplication. So I'm going to check. We are inside of the green area. Let's go to the next. The next is it's inside. Let's refresh and fix. Yes, we are inside of the green area. Then manifold cost. First chart for manifold cost is giving us this spot here inside, but it's not organized. Let's see. It's touching the green area. It's in the border. It's okay. Next, it's the manifold well versus number of well. Let's refresh. It's in exactly in the curve. Next is manifold comparing with the number of wells and water depth. Let's refresh. It's inside of the green area. And next is flow line. First flow line. It's a little bit high. It means, depending on the BOED, it means you are paying too much for that. Probably the data we introduce is not properly the adequate, because for this quantity of project and wells, with this hydrocarbon throughput, you are paying too much, or your estimate is wrong. The two possibility. Let's go to the next. Refreshing is a bit lower in terms of kilometers distance to host. Okay, so probably you have to put some money on your estimate. You have to review, but it's in yellow because it's a percentage here. You can say it's a warning, just a warning. Next, flow lines are umbilical, but using the parameter we mentioned, and is almost on the top out of the data. So it could be this confirms that the 8 kilometer we used is too much, but it's okay. So it's the way to make the benchmarking. So it's if we come back to the cost estimation, we can say this 80 was too much. We can say it's could be less, let's say 60, and the cost is less, and the distance to host probably is too much. But it's an input. It's just when you work with real values, you have something that from engineering design is logical. So since we are doing just an exercise, we are trying to figure it out how the engineering is. But I suppose it could be 25 here and here no more than, let's say, 50. If we change 25 for distance and 50 for the length, let's see how our data change. Let's go there and let's modify this 24 by 25, and the other data is at the host, and this 50. Okay, so let's see, it's not but with doing that the estimate change not much. The estimate is the same, but we have 80 because the total amount of the surf is this, and it doesn't depend on the umbilical. It means the project is this amount, but something here, the umbilicals and flow line is this, and you have other cost increasing. I don't remember how much was at the beginning, but I put this section just to say that in other cost we have the difference, and because this is coming from data, and then these three are coming from real data, and if the difference there is a difference, you have to put somewhere, and I have defined this column as other cost to say that is the project, the surf was 306, so we have a total amount of 80 here. So that's the way that the tool works. And if we work here again with a chart depending on the flow lines. So if we go to flow line, the first one, let's now compare. No, this not, because it doesn't depend. This one, now it's inside of the line, and this is closer. Let's compare. Yeah, it's inside of the green area, and this, which depend on the kilometers to host, now it's inside of the green area. So that's the way the cost estimation benchmarking works. See you next lesson, and have a good day.